These are the practice problems for lesson 3. It says for problem number 1, segment AB, so here's segment AB right here, is 3 centimeters in length. Point O is the center of dilation. So here's point O, that is the center of dilation. How long is the image of AB? So the copy of AB, or the image of AB, when it gets dilated either out, or in one case it gets dilated in, it gets smaller, after the dilation width, and A is a scale factor of 5. All right, so as I said a moment ago, the distance from the center of dilation to the point A here, that's the unit. Whatever length it is, it could be 5 centimeters, 2 centimeters, 15 centimeters, whatever it is, but that's 1 unit that's getting scaled 5 times. And the distance from O to B is then going to be the unit that gets scaled 5 times. Whatever that length is, it's still going to be the thing, or the unit, that gets scaled 5 times. All right, so A, 5 times A, whatever this distance A is, this is 2 times, 3 times, 4 times, 5 times. And B, whatever this distance B is, this is 2 times B, 3 times B, 4 times B, and 5 times B. So this length up here then is 5 times this length, and this length is 3 centimeters. So it's 3 centimeters times the scale factor, which is 5. Now you can imagine drawing parallel lines from here to here. That's going to be 3 centimeters. From here up to here, that's going to be 6 centimeters. From here to here, that'll be 9 centimeters. From here to here, that will be 12 centimeters. And then this point will finish it out to be 15 centimeters. So this length is 5 times as long as AB. Scale factor of 5, any distance of 3 centimeters makes it 15 centimeters. All right, the next one is a scale factor of 3 7/10. So that means, remember, this is the unit that's going to get multiplied by the scale factor. So it's 3 centimeters times 3 7. No, it's not 3 centimeters, sorry. It's the length A times 3 7/10. Well, this is 1 times A, 2 times A, 3 times A, and I'm going to just estimate that 7/10 is about right there. So I'm using the same figure I just used, but now the scale factor is 3 7/10. The length B is also going to get multiplied by 3 7/10. So this is 1 times, 2 times, 3 times, and this is 7/10 times the distance from O to B. And so this length up here is the length that is 3 times 3 centimeters times 3 7/10. Well, 3 times 3 is 9. 3 times 7/10 is 2 1/10. Add those two together. So this length is 11 1/10. And just like before, you can imagine drawing parallel lines up to here. This would be 3 centimeters, sorry. This would be 2 times 3, or 6 centimeters. This would be 3 times 3, or 9 centimeters. And this would be 3 times 7/10, which is the remaining 2 1/10 centimeters, to make this length 11 1/10 centimeters. So notice that you're multiplying this to get the image length. You're multiplying 3 centimeters times the scale factor each time. The next one, what if the scale factor is 1/5? So now you're going to make this smaller. You're going to make it 1/5 the size. And so this length from O to A is going to be 1/5 that size. So you just estimate this down to about 1/5. And from O to B, this length is going to be 1/5 the length from O to B. So about down to here. This line has to be parallel with this line. So you can imagine they're right there and make them parallel. So this length then is going to be 1/5 of 3 centimeters. Well, 1/5 of 3 centimeters is 3/5 of a centimeter. Another way of looking at that is 3 times 1/5. So that's 3/5 of a centimeter. So if you imagine drawing a line that's parallel right up to here, this length right here is going to be 3/5 of a centimeter. Imagine going out a little bit more, that's going to be 1 centimeter. And then cutting that in half, that distance in half, that's going to be 2 centimeters. And that would be 3 centimeters, if you follow what I'm saying. All right, the last one is what if you have a scale factor of s? Well, I tried to prepare you for this question because I knew it was coming. Is each time, what are you multiplying the scale factor by? To get the length, you're multiplying the scale factor by 3. So it's the scale factor, first case it was 5 times 3, next it was 3 7/10 times 3, so those are the scale factors, and 1/5 times 3. So the image is going to be 3 times whatever the scale factor is, that many centimeters actually, so it's 3s. All right, problem number 1. Practice problem number 1 from lesson 3. Okay, this is problem number 2 from lesson 3. So you have these 2 points, A and B, and so this is going to provide you with some practice of using the language and understanding that these dilations move along lines. So the first one says plot the point for each dilation described. Plot means place the point. And so where is C if C is an image of B and A is the center of dilation and a scale factor of 2? Okay, so A is the center of dilation, so that's the starting point, and B is the point that is getting dilated. It's the one that's moving either towards A or away from A in a straight line. And that distance is going to be the unit length. That's going to be what gets multiplied by the scale factor. So in this case, the scale factor is 2. So that gets dilated with the scale factor 2. So this length is going to get doubled. It's going to be from A to B, and then from B to C. It's going to be the same length. So the total length is twice as long as the length from A to B. So C is an image of B. Now, if you flip it around, and now we're going to make B the center of dilation, and A is the point that gets dilated. So B is the center of dilation, A is the point that gets dilated. So now you're going to go in this, and the scale factor is 2. So you're going to start at B, center of dilation. This is going to be the unit length once again, but this length is going to get doubled because it's a scale factor of 2. And so D is going to end up here. So it's twice as far away from B as A is because it's a scale factor of 2. And so now they're going to take B and find the image of B after it gets dilated with a scale factor of 1/2. So now the image of B is going to move closer to A, and it's going to be half the distance away from A. So it's right here. So B goes to E. So this length, this is the unit length, the scale factor is 1/2. So this length is going to be 1/2 of the original length. So B to E, scale factor of 1/2. And this one they're going to do the same thing. So what's a scale factor of 1/2? Where does A end up if it takes A to what they're going to call F? So the scale factor is 1/2. And so where's the image of A with a scale factor of 1/2? So B is the center of dilation. A is what's getting moved, what's getting dilated, but it's a scale factor of 1/2, so it's going to move closer to B. And so the distance from B to F is half the distance of B to A because it gets scaled by 1/2. So you multiply this distance right here by 1/2. So this is half the length. Okay, just some practice. Understanding that these dilations move along lines or rays. And the center of dilation is the starting point. And what is getting dilated, what's getting moved, that's the original unit that gets multiplied by the scale factor. So B is what gets this length from A to B is what gets multiplied by the scale factor. And this length from B to A is what gets multiplied by the scale factor. And notice each of these are on the line, and each of these are on the line. Okay, problem number 2 from lesson 3. Okay, this is practice problem 3 from lesson 3. And the directions are pretty simple. It just says draw a polygon, make up your own polygon. I chose to make a 6-sided shape, which is a hexagon. 1, 2, 3, 4, 5, 6. And then it says make a perspective drawing. And perspective drawing just means choose a center of dilation that's outside the polygon. So I chose this point right here, B, or I'm sorry, this blue point right here. And then dilate it, choose a scale factor, and dilate it from that point. So I chose to use a dilation factor. First of all, I just drew the lines from the center of dilation to each of these points. So those are the unit lengths. That's what gets multiplied by the scale factor. And I just chose just a simple scale factor of 2. So I doubled each of these lengths. So this length gets doubled to here. This length gets doubled to here. This length gets doubled to here, to here, to here, and to here. So scale factor of 2. And then you just connect these points. Connected the points. And from there, you can come up with some scheme in which to shade them and try to bring out the three-dimensional perspective aspect of the drawing. I had trouble with that. I tried a couple of different things. I tried this, and I tried this, and neither of them I really like. So if you have an exploratory art class, maybe your art teacher could help you out with this a little bit. These are single point perspective drawings, and it's something that they actually usually do in art class. So take it into your art teacher and see if you can't come up with an interesting way to shade these and do some other interesting perspective drawings. So this is problem number 3 from lesson 3. This is practice problem number 4 for lesson 3. It says that triangle ABC, and actually this is triangle ABC. This is triangle ABC up here. It's not filled in. Is a scaled copy of triangle DEF. So this is DEF. Side AB measures 12 centimeters and is the longest side of ABC. Side DE, right here, measures 8 centimeters and is the longest side of DEF. Well, if that's the case, then this scale factor is 3/2. You're going from an 8 centimeter side to 12 centimeter side, so that factor is 3/2. 12 out of 8, or 12 to 8, is 3/2. All right, so to find the center of dilation, draw a straight line between the vertices. This is going to form a vertex right here, this point, and it's going to intersect at the center of dilation down here. So do the same thing here, and where they intersect, that's the center of dilation. And so the distance to this vertex in the triangle ABC is going to be 1/2 again as far as the distance from here to here. So it's going to be 3/2. Right, so I'm going to use docere to find 1/2, what the midpoint is from this point right here to this point, this line segment. So we'll snap to the midpoint so I can use that. All right, so this is a line segment that's 1/2 the distance. From here to here is 1/2 the distance of this length all the way to this vertex here. And then the vertex in triangle ABC is another of those lengths. So this is 1/2, this is 2/2, and this length then is 3/2. So this is 3/2 the length of this length right here. And, all right. So then if you just connect the points, this is A, B, C up here. So this length is 12 centimeters. This length here is 8 centimeters. So 12 to 8. You can simplify 12 to 8 by dividing by 4. 12 divided by 4 is 3. 8 divided by 4 is 2. So the 4's cancel out, and you're left with 3/2. So the scale factor is 3/2. Now to go the other way, to scale triangle ABC down to DEF, it is the reciprocal, so 8/12. So 8/12, again, divide 8 by 4, that's 2. Divide 12 by 4, that's 3. These 4's cancel out, and it leaves you with 2/3. And so notice in scaling, going one direction, it's one scale factor, But if you want to return to the original and go the other direction, the scale factor is the reciprocal. So in this case, it's 3/2 to go from DEF to ABC, and it's 2/3 to go from ABC to DEF. And you can see that. Go back to this length here. This length from F to the center of dilation is 2/3 the length from the center of dilation to C. On the other hand, the length of the center of dilation to C is 3/2 the length of the center of dilation to F. So they are reciprocals. All right, so that's problem number 4. That's problem 5 from lesson 3. And they give you this figure, and they ask you to figure out the missing angles, the measure of the missing angles. When you look at this figure, whenever you see two lines that intersect, there's two things to think about. One is that there are vertical angles involved, and the other is that there are supplementary angles involved. Well, vertical angles means that the angle through the intersection on the opposite side, those two angles are going to be equal. Supplementary angles means that they add to 180 degrees. Two angles that add to 180 degrees. It goes 180 degrees, or halfway of a circle around. So this side opens up to this line right here. So it forms a straight line. It's 180 degrees. All right, so B degrees, easiest place to start. That is a vertical angle with 102 degrees. So those two angles have to be equal. All right, so this angle C is supplementary to 102 degrees, and so is angle A. They both are equal to each other because they are also vertical angles of each other. So to get to 180 degrees from 182 degrees, you just have to add 78 degrees. 102 degrees plus 78 degrees equals 180 degrees. So they are supplementary, and A is equal to C, so that makes C 78 degrees. So just key into vertical angles and supplementary angles. These two angles are supplementary, these two angles are supplementary, these two angles are supplementary, and these two angles are supplementary. So problem number 5. This is problem number 6 from lesson 3. It says, show that these two triangles are congruent and then find the missing measurements. So the missing side lengths of this triangle and the missing angles of this triangle. Well, to show that they're congruent, you can take them through a series of rigid transformations. So one is a translation. So translate this triangle down so that A maps to D. And then then this is a reflection. So this is a line of reflection right here. And so this triangle will reflect over and map to this triangle. So that proves that they are congruent triangles. So what that means then is the corresponding angles are going to be equal. So this angle right here, these two angles correspond to each other because they will match after they reflect over this line of reflection. So this one is 34 7/10 degrees. This angle right here matches this angle or maps to that angle. So this is 108 4/10 degrees. And this angle way over here maps to this angle. So it's going to reflect over and fall right here. Remember, a reflection, you move in a perpendicular direction to the line of reflection, and it's an equal distance on the other side. So if this is the line of reflection, this is an equal distance. So this is 4 units to here. So this is going to be 4 units to here. So this is 36 9/10 degrees, which makes this angle 36 9/10 degrees. And the same is true for the side lengths. These side lengths are the same. It gets translated down here. So this is 5. That makes this side length 5. This is 3, and actually you can count them in this case. And that length is 3. This side length is 3. And finally, this side length is 3 2/10. So this side length has to be 3 2/10. So they are congruent, and the angles and the side lengths have to be congruent. They have to match because they are congruent triangles, meaning they are equal to each other. Problem number 6.